Hello friends, today we're going to touch a quadratic equation which people always call a almighty formula. So how do we prove it? It is being proven from the equation of a quadratic which is ax squared plus bx plus c equals to 0. This is about just using a form of substitution and completing the scale just to get the equation. So let's start now. The very first thing to do in this equation is just to collect like that. Let all variables with x be at the left hand side and the constant be at the right hand side. Let's do that. So we have our ax squared plus bx equals to minus c. That is the first step. Now the second step is just to divide all through by a to eliminate the coefficient of x squared, so that we can always have x squared having this coefficient to be 1. So let's do that. Divide by a, divide by a, divide by a. This a cancels this a. So we're going to have x squared plus bx all over a equals to minus c all over a. So next is to add half of the coefficient of x to both sides of the equation. So let's do that. We now have x squared plus bx all over a plus half of the coefficient. We now have b all over 2a squared equals to minus c all over a plus b all over 2a all squared. So we've not done any magic. If you look critically at the equation, you discover that we added this, which is still the same. It's just an attempt to complete the square at the left hand side. So let's do that. We now have this is the same thing as x squared plus bx all over a plus b squared all over 4a squared equals to, bring this here, b squared over 4a squared minus c all over a. So there's no magic in this. We've just opened the bracket, and this time around, looking at this critically, you know that it's a complete square. We cannot complete the square. It's still the same thing as this is the same thing as s plus b all over 2a. This time around, you can always scale like this, because if you open this, you are going to have this in return. If you factorize this, you get this. If you open this, you get this. So that will be equals to, you now find the LCM of these two together. You have 4a squared here. What do we have? We have 4a squared is common. Is the LCM, the lowest common multiple. 4a goes in 4a squared, that is 1. 1 multiplied by b squared, you have b squared. Minus a in this, we have 4a. 4a multiplied by c, we have minus 4ac. So the next thing to do now is just to, you see, this is being raised to the power of 2. This is being raised to the power of 1 altogether. If you look at this now, it's raised to the power of 1. The next thing to do is just, you can raise both sides to the power of half. So when you raise both sides to the power of half, this half, the 2 will cancel this 2. You now have s plus b all over 2a equals to, it now take the square root of this because it is raised to a fractional index. So when you change from fractional index to root symbol, you're going to have this. But this time around, it's going to be plus or minus the square root of b squared minus 4ac all over 4a squared. That is it. S plus b over 2a equals to plus or minus square root of b squared minus 4ac over 4 squared. It's as good as when you are finding the square root of 4. It's not going to give you only 2. It's also minus 2. That is why we're having plus or minus here. So the next step now is to say that x now, make x the subject of formula, is going to be minus b all over 2a. You are picking this, change it to the right hand side. So it's going to give you minus. That is why we're having minus here. Then plus or minus square root of b square minus 4ac. Remember that this one has a square root, which is going to give you 2a, ordinary 2a. So you are going to have 2a here. So x is equal to minus b over 2a plus or minus square root b square minus 4ac over 2a. Then looking at this critically, we can always find the LCM. X now will be equals to minus b plus or minus square root of b square minus 4ac. Remember that this 2a is common to both, so you can also put 2a, which serves as the almighty formula that everybody is quite afraid of, even during the exam. You see, applying this, it becomes a difficulty in examinations, whereas somebody else can always come up with the proof using a completing the square and some necessary substitution of solving the equation, as simple as that. So anytime you are giving the examination that you have to find either the solution to quadratic equation, because of having plus or minus here, you are going to have two values, which is peculiar to quadratic equation, unlike a linear equation where you always have one solution. So in case of this, you always have two values of x. As simple as that. Thank you very much. I want to refuse my name, popularly known as Ogalas of PFC writer worldwide. You can always watch my mathematics videos on Heraf Online Mathematics on Facebook. You subscribe to my YouTube channel where you can always enjoy my mathematics videos. Thank you. God bless.